Hello, my name is Ayushman and I am to uh, uh, do a code explanation for my take on Caesar Cipher. So, this is the code for the Caesar Cipher that I have written in Rust. Talking about the imports, first import is eFrame and we are importing eGUI from eFrames. So, eFrame is basically it provides components for the GUI or the graphical interface, such as the text areas and the buttons. Then for Unicode segmentation and Unicode normalization, they provide tools for handling grapheme clusters. So grapheme clusters would be basically user perceived characters. So for example, in different languages we have certain characters which have certain like acute accents. So what grapheme clusters do is that they separate the uh, acute accent from the actual letter and groups it together. And normalization actually helps convert to and fro of this what do you say the segmentation. Then talking about the struct, we first we do a struct called alphabet range. So it has three data values, that is the start, end and the size. So the start is actually like the first character of the range, end is the last character of the range, and size is the number of characters in the range, which is basically calculated as end minus start plus 1. Since we are doing it in Unicode, all of them will be in a series, so that is why we can directly calculate size in this manner. Then we have the implementation of alphabet range. So first we create a function called new. So it is basically a constructor for a new alphabet range, and it calculates the size, as I said, based on the Unicode values of start and end. Then we have another function called contains. So what contains does is if it checks if a particular character, let's say C, falls within the range. So whatever characters we have input, it will check if it falls within the range or not. Then the last function in this implementation is shift. So what shift basically does is it computes the character's zero based position within the range, which is basically denoted by POS. We have another variable called as base, which is basically the start position of the range. Then we have something called a normalized shift. So normalized shift we have implemented so to ensure the wrapping. Proper wrapping is necessary because it might be possible for the characters to go out of range from the intended range that we have selected. So that is why we have created this normalized shift, just to ensure that uh, the wrapping is done properly and all the characters remain within the specified range. Then we have a new position, which basically does the wrapping using modulo, and then in the end we just convert it back to the new position of the character. So that is the implementation of alphabet range. Then we have another structure called Caesar Cipher. So it has two fields called ranges and shift amount. So ranges is basically the a collection of alphabet range objects, and it represents like supporting alphabets, whereas the shift amount denotes by how much should the characters shift. So usually Caesar Cipher has a fixed value for 3, but in this implementation what I have done is that the user can select their own choice of shift value, and they can shift according to the shift number. Then we have implementation of Caesar Cipher structure. So it has a function called new. So what the new function does is it basically initializes the cipher with predefined alphabet ranges and a shift amount. Then we have something called so as you can see, that we have already specified all the ranges for the characters, different characters. Currently, we are only focusing on three types of characters, which is Latin, which is used in many languages, including English. Then we have Cyrillic, which is used in languages such as Russian, and then we have the Greek alphabets. So, then moving on, we have another function called the process text. So, what process text uh, does is, first it will determine the shift direction, that if we are trying to encrypt or if we are trying to decrypt. So based on that it will perform the shift, and then we normalize the input text. So as I said, we have grapheme clusters, right? So what we'll do is we'll convert it to grapheme clusters for ease, and then we process these grapheme clusters, right? So each grapheme cluster is processed in in a particular manner. So first we extract the first character of the grapheme, which is like the main character, without the accent. So after that we check if the character belongs to any of these alphabet ranges, and if it does, we shift the character based on the shift that was given, and then we reconstruct the grapheme with the shifted character and any other remaining characters. Like if there are any other characters in there, we will reconstruct the grapheme properly. Then in the end what we do is we reassemble the text. So we combine all the processed graphemes into a new string, and then we normalize the result back, and we ensure that the composed characters actually become a single character back again as it was in the start. So this is what all happened. Then we have a public structure, which is a Caesar Cipher app, and it has the fields called, first is input text. So it will store like the user provided text for processing, basically our input. The output text will store the result of the encryption or decryption, and will basically give us the output of the entire encryption or decryption process, whatever we choose. uh, Mode basically tracks whether we are running it in encrypt mode or decrypt mode. Shift amount will store the number of shifts that we want to decide, and Cipher is basically the Caesar Cipher instance, as we have talked about earlier, the implementation of Caesar Cipher where the cipher will actually work. So first is the default implementation. So what default implementation will do is, it will initialize the app with empty input and output, set the default mode to encrypt and the default shift to 3. So as soon as we start the GUI, these values are what we will start with, right? And then we have the GUI logic. So for GUI logic, first we have the heading part. So it will display Unicode Caesar Cipher at the top. The input text area, which will basically provide us the input for like a text box for input, and if we want like encrypt or decrypt mode. The shift amount control, where we basically like choose how much we shift by, and it will basically update our Caesar Cipher instance by whenever we change the shift value. Then mode selection allows us to choose the type of mode, be it encrypt or decrypt, and it will basically update the mode field of the Caesar Cipher structure accordingly based on our choice. Then we have a process button. So process button basically runs our code and encrypts or decrypts based on whatever choices we have chosen, and then the output text area will basically show us the output. We have a small section called supported scripts as well. So what supported scripts does is, it will basically show us the what all scripts are supported. As we can see, it is just a simple print statement. So we are just telling that Latin characters from A to Z, similarly Cyrillic characters and Greek characters will be presented. Then so this is basically what our code will do. So as a summary, we have like a proper handling for graphene clusters and combining characters to accommodate languages other than English, or other use characters other than the Latin characters, which can be done through the Unicode implementation. So then we have a real-time adjustment. Basically, we can shift the shift amount can be changed dynamically based on user's choice. So instead of sticking to a fixed number of 3, we are giving a choice of like whatever the user wants, and we are providing a very simple GUI which is easy to understand with all the defaults and stuff predefined. Now moving on to the main function, where we are actually just running all of this. We're calling back. So first is again the import for eGUI, so that we can run all the GUI components. And mod GUIs, since the previous file which we talked about is named as GUI.rs, which is a Rust file, so we'll be calling that in so that we can call on the functions and implementations that we have defined in that file, right? So then we have the main function block. So in the main function block, what we're doing is we're defining configuration options for our GUI application. So here we'll decide things such as the window size, vsync, sampling, and whether if we want to like resize the window or not. So first what we're doing is we're setting the initial window size to 800 into 600 pixels. So as soon as we start the program, or as soon as we run the program, this is what we'll see. After that, we see that the minimum window size. So basically we set a minimum window size that the window cannot be resized further down. So the minimum that we can go is 400 into 300 pixels. After that, we have enabled vertical synchronization, or vsync, by default. This will reduce any screen tearing during rendering. So this program or this GUI will be rendered, and there might be chances for tearing and all. So by enabling vsync, we try to prevent any kind of tearing that might take place. Similarly, for multi-sampling as well, we enable 4 times multi-sampling for any kind of anti-aliasing. So the edges of the GUI are smoothened out, and it looks good and appeals to the eye. As we can see that resizable, we have enabled it to be resizable. That means that user can change its size based on their preference, but it cannot go down below the further window size that we have fixed before. And then we can see the iframe run native. So what we're doing here is it will basically start the application with the provided titles and options, and also the GUI options that we have defined previously in our GUI.rs file. So what we're doing is we're basically starting the application with the default settings that we have run. So this is my program, and now we'll move on to the demo section. So now coming on to our demo section, what we can see is, as I said, we have a title called Unicode Caesar Cipher, input area, shift amount, encrypt, decrypt, which is the modes. Current mode by default is set to encrypt, and the shift amount by default is 3. The process text button, output text area, and the supported scripts, which are Latin, Cyrillic, and Greek. So now, starting off with, we are going with Greek characters. So this is the Greek word for good morning. So for this instance, we'll be just going with the default values and process the text, and we get an output, right? So to check if the output is like the actual value or not, we put it back into the input text area and see if we go to decrypt, we'll get the same thing or not. So when we press on process text, we get the same input text back as the output. This means that for Greek characters it works well. Now we move on to our Latin characters, which is as it is good morning. uh, in this case we'll be changing the parameters a little bit. So what we'll do is we'll change the shift amount to 5. Then we go to encrypt and process the text, so we get our output text back. As you can see, it is a bit jumbled up, but that is because this is how it works. Now to test it, we put the output back into input and decrypt it to see if we get the input back. So as we can see, we got good morning as the output, which means it works for Latin as well. Now we'll be moving on to the last set, which is Cyrillic, and this is the Cyrillic, like the word for good morning in Cyrillic, which basically in Russian we did this. So now we'll again change the shift amount, let's say 17, and put in encrypt mode and process the text. So we got an output back. So again, to test it, what we'll do is we'll copy the output and paste it back into the input text box and decrypt it to see if we get the input back. So now we can see we got the input back, so it works properly.